I, Dr. Sourav Gautam, Assistant Professor, Department of Chemistry, School of Basic and Applied Sciences, Maharaja Aghasin University, Baddi, Soul. And today's my topic is group theory. Under group theory, we are going to discuss symmetry elements and symmetry operations. So, first of all, what is group theory? What is group? It is collection of elements. It's called group. It is the study of symmetry. Fundamental of group theory are developed by Yves Galois. It is purely mathematic concept which has wide application in physical sciences. When applied to chemistry, it can be used, for example, to predict whether or not a molecule has a dipole moment, to predict if a molecule will show optical activity, to drive selection rules for spectroscopic transitions, to determine which atomic orbitals to be used to construct hybrid orbitals, to predict which molecular vibrations lead to IR spectra, etc. So, friends, as we know, it is the study of symmetry. So, what is symmetry? Symmetry is when a shape looks identical to its original shape after being flipped or turned. Is called symmetry. Symmetry elements are geometrical entities, axes, which are related to the effect of symmetry operations. These are a line, a plane, or a point with respect to which one or more symmetry operations can be carried out. As we know, nature loves symmetry. Most objects found in nature have symmetry. Symmetry is associated with beauty. For example, flowers, diamonds, butterflies, snail shells, leaves, etc. are all beautiful, highly symmetrical because of harmony and attractiveness of their form and proportions. So, what is symmetry elements and symmetry operations? Symmetry elements are static entities, and while the operations are dynamic. A symmetry element is a geometrical axis, geometrical entities, such as it is a line, a plane, or a point, about which one can perform an operation of rotation, reflection, or inversion. So, a symmetry operation is a movement of body, maybe an object, a figure, a function, such that after the movement have been carried out, every point in the body is coincided with an equivalent point for the same point of the body in its original form. Means it is a movement of a molecule about and symmetry elements, such that resulting configuration is indistinguishable from the original. A symmetry operation will transform a molecule into an equivalent or identical configuration. So, for example, in symmetry elements and symmetry operations, symmetry elements are identity, proper rotation axis or axis of symmetry, mirror plane or plane of symmetry, inversion center or center of symmetry, improper rotation axis or rotation reflection axis. Identity, it means same, doing nothing. Operation, in symmetry operation, doing nothing, as it is abbreviation for identity is capital E. And proper axis of rotation, rotation about the axis through some angles. It may be 60, 90, 180, 120. And planosymmetry symbol is sigma. That is reflection about the plane. And I is the center of the inversion. inversion center or center of symmetry. That means it is a inversion is a reflection about a point. An improper rotation axis or rotation reflection axis symbol is SN. And rotation about an axis through some angle followed by a reflection in a plane perpendicular to the rotation axis. So first of all, we are going to discuss identity. Capital E, symbol is E. This is an operation which brings molecule back to its original orientation. This operation does nothing. It is the simplest of all the simple elements. It is the only element operation possessed by all molecules. It is denoted by capital E. For example, 1-chloro, 1-bromo, 1-fluoromethane, as shown in this figure. And second one is axis of symmetry or proper axis of rotation. And symbol is CN. In proper axis of rotation, it is called n-fold rotation axis. If the rotation of a molecule about an axis through some angles results in a configuration which is indistinguishable from the original, then the molecule is said to possess a proper rotation axis, and it is denoted as Cn, where n is the order of rotation axis or number of rotations. So in proper axis of rotation or proper axis of symmetry, it is an axis around which the rotation of the molecule, we choose clockwise rotation as positive and anti-clockwise rotation as negative. So it is a rotation of the molecule by an angle theta, where theta is 360 by n, and n is order of axis, number of rotation. So it is a rotation of a molecule by an angle theta gives an equivalent configuration where n is the order of axis. It is not, and this is axis of symmetry is denoted as Cn, and rotation about an axis by an angle 360 by n, and n may be 2, 3, 4, 5, 6, means number of rotations. So, for example, in homonuclear diatomic molecule like H2 or either water, there is C2 rotation, means two-fold axis of symmetry. For example, in water, in water, in water molecule, we have two-fold axis of symmetry. As we can see in this first figure, yellow line is principal axis, and this red sphere is oxygen, and white grayish sphere is two hydrogen, hydrogen 1 and hydrogen 2. So in water molecule, we have two-fold axis of symmetry, that is C2 symmetry, passing through oxygen atom bisecting an angle HOH. In this figure, देखिए येलो लाइन है, ये पास कर रही है एंगल HOH, means hydrogen, oxygen, hydrogen. If the molecule is rotated by an angle theta 180 degree, अब इस येलो लाइन को पकड़ के अगर हम 180 डिग्री की रोटेशन करेंगे तो क्या होगा, दिस स्फीयर H1 फर्स्ट स्फीयर क्या आ जाएगा, सेकंड की पोजीशन पे आ जाएगा या सेकंड फर्स्ट की पोजीशन पे आएगा, और अगर एक और सेकंड रोटेशन देंगे तो क्या होगा, जो फर्स्ट स्फीयर जो पहली पोजीशन पे था सेम वहीं पे सेम पोजीशन पे आ जाएगा, और सेकंड वाला सेकंड पे चला जाएगा और अपनी आइडेंटिकल कॉन्फ़िगरेशन ले लेगा. सो कितने फोल्ड के बाद, आफ्टर टू रोटेशन वी कैन गेट आइडेंटिकल कॉन्फ़िगरेशन. So next one is threefold axis of symmetry. There is some common examples. There is common in planar They are quite common in planar AB3 molecules, for example, BF3, NH3, etc. So, for example, in BF3, uh, we have example in BF3. BF3 possess a threefold axis of symmetry. For example, fan, like BF3, fan. Three, it possesses a threefold proper axis of rotation passing through the boron as in figure 1. It is passing through the boron atom and it is perpendicular to the plane of molecule. In addition, C3, देखिए फर्स्ट में जो ये रेड पॉइंट है बोरोन पे यहां से बाहर की तरफ आएगा, ये है जेड एक्सिस, ये एक प्लेन है, BF3 एक प्लेन है, ये जो जेड एक्सिस है इसके परपेंडिकुलर होगी, जो एरो दिया है ये है उसकी रोटेशन। तो देखो 3 रोटेशन के बाद क्या करेगा, ये अपनी सेम पोजीशन ले लेगा। सो इन BF3 आफ्टर 3 रोटेशन वी कैन गेट आइडेंटिकल कॉन्फ़िगरेशन। तो इसे क्या कहेंगे, थ्री फोल्ड एक्सिस ऑफ सिमेट्री, थ्री फोल्ड सिमेट्री। Like in addition to C3, BF3 molecule possess 3 more two-fold axes which are perpendicular to the three-fold axis. Like in figure 2, देखो एक फ्लोरीन बोरॉन एटम, एक एक्सिस पकड़ो, एक रोटेशन क्या हो जाएगा, फर्स्ट ये वाला फ्लोरीन यहां चलाएगा और ये वाला इस तरफ आ जाएगा, और एक रोटेशन इससे फिर से देंगे तो ये अपनी आइडेंटिकल कॉन्फ़िगरेशन ले लेगा, आइडेंटिकल पोजीशन ले लेगा, सेम एज इट इज। सो 1C2 इज एट 1 पोजीशन, सेकंड पोजीशन सेम, एंड थर्ड पोजीशन। तो कितने सीट हो गए, 3। सो इन एडिशन ऑफ C3 देयर इज 3C2 which is perpendicular to the threefold symmetry axis passing through boron and each of the fluorine atom. These axes are in plane of the molecule, right? So in case of molecule with more than one axis of symmetry, the axis with the highest order means minimum angle of rotation is called the principal axis. It means the principal, what is principal axis? जैसे हम कंसीडर करें जेड एक्सिस इज प्रिंसिपल एक्सिस। अब किसी भी एक्सिस को देखें, जिस एक्सिस पे द एक्सिस अबाउट विच मैक्सिमम नंबर ऑफ रोटेशन आर कैरिड आउट इज कॉल्ड प्रिंसिपल एक्सिस, एंड रेस्ट ऑफ द एक्सिस आर सब्सिडियरी एक्सिस। सो व्हाट इज प्रिंसिपल एक्सिस, ऐसी एक्सिस जिसके इर्द गिर्द around which maximum number of rotation is carried out and is called principal axis. So generally हम z axis को क्या करते हैं, principal axis consider करते हैं, and rest of the axis, y axis, z x axis, जितनी भी axis है वो क्या है, subsidiaries. Yes, right. So in next example, BF3, NH3 and BF3, there is a threefold axis of symmetry, and in NH3 same as after 3 rotation we can get identical configuration. In NH3, ammonia molecule has a C3 axis passing through nitrogen atom, although it is not a planar molecule. The geometry of ammonia is pyramidal and angle HNH is about 107. But the identical configuration is obtained by rotating the molecule through 120 degree on C3 axis. देख सकते हैं आप फिगर में 3 रोटेशन के बाद आपको क्या आइडेंटिकल कॉन्फ़िगरेशन मिल रही है, रोटेशन बाय एन एंगल 120 degree. We can get identical configuration. In next case, like four-fold axis of symmetry, xenon, for example, xenon tetrafluoride. As we can see in xenon tetrafluoride, it is the example of four-fold axis of symmetry. It is a square planar molecule It contains a four-fold axis of symmetry, four-fold axis as shown in this figure. This is z-axis. This is a plane. Z-axis is perpendicular to molecular plane. This plane. And if we rotate about z-axis through an angle 90 degree, this one 90 degree, 90 degree, 90 degree and 90 degree. अगर इसको हम 4 रोटेशन देंगे तो क्या करेंगे, हमें क्या मिल जाएगी, इक्विवेलेंट कॉन्फ़िगरेशन. So principal axis C4, we can get principal axis about which the rotation is carried out four times. That is called fourfold symmetry, axis of rotation. So in xenon tetrafluoride there is a fourfold axis of symmetry. So इसके अलावा there is a twofold axis of symmetry. Twofold, twofold, 4C2 axis, like this axis, xenon fluoride, xenon fluoride, xenon fluoride, and xenon fluoride. Xenon fluoride, this one, 1C2, 2C2, this plane C2, and bisecting this plane between one fluorine, xenon fluorine, C2, and same as it is in this side, C2. So there is a C4 and 4C2 axis of rotation in xenon tetrafluoride. So consider an example of cyclopentadienyl. In this C5H5, it possesses a C5 axis, that is principal axis. In first figure, there is a C5, means 5 rotation के बाद we can get original configuration. So C5 principal axis, which is perpendicular to the plane of the molecule, and it also has 5C2, 5 subsidiary axes like this. Second figure, C2, 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 and C2. There is a 5C2 axis, subsidiary axis, each passing through one carbon atom. This carbon, C5, 5 carbons, and middle of the opposite edges. So, for example, this axis, subsidiary axis, it passing through one of the carbon atom and middle of the opposite edges. That is first C2, second, third, fourth, and fifth. 5 C2. So each passing through one carbon atom and the middle of the opposite edges in the molecule plane. And in benzene, 6-fold axis of symmetry as same जैसे हमने किया cyclopentadienyl में 5-fold axis of symmetry, same in benzene ring. In benzene, there is a principal axis, that is C6. It means after 6 rotation about the principal axis, we can get same configuration, identical configuration. So after 6-fold, we can get identical configuration. So it is called 6-fold axis of symmetry. So in benzene, there is a 6-fold axis of symmetry, C6, which passing through the center of the hexagonal ring and is perpendicular to the plane of the ring, this point. It is principal axis also in benzene besides C6. C6 के अलावा there is a 6C2. कौन से? Axis which passing through one end of carbon and second end of carbon. First, second, and third. After 2 rotation of 180 degree, we can get identical configuration in C2. So beside C6, there are 6 two-fold axes of symmetry, out of which 3 passing through the center of the benzene molecule and 2 opposite carbon atom in this second figure, and the remaining 3 passing through the center of the molecule and middle of the 2 edges, opposite edges. All the C2 axes are in plane of the molecule in figure 3. So there is a C6 and 6C2 in 6-fold axis of symmetry. So जैसे कि principal axis is the axis around which maximum number of rotation is carried out is called principal axis, and rest of the axis is called subsidiary axis. So these are the symbol of the proper axis of rotations: C2, C3, C4, C5, C6. There is order of rotation axis in this table: 2, 3, 4, 5, and 6, and different angles through which rotation is carried out: 180 degree, 120 degree, 90 degree, 72 degree, 60 degree in C6. In general, CN axis can generate n operations: CN, CN2, CN3, CN4, CNN. And CNN is identical. If C22, it means दो रोटेशन के बाद वो अपनी सेम कॉन्फ़िगरेशन ले लेता है, आइडेंटिकल शेप में आ जाता है. So CNN either C55 that is identical, C66 that is identical, and so CNN is always is identical. CNN plus 1 is CN, and CNN plus 2 is CN2, and so on. So as also example of PTCL4, in this red line is z-axis, so this red line is z-axis. Cn is rotation about an axis by an angle of 2 pi by n. In this z-axis is z-axis C4 in red line, about which 4 rotation is carried out, and then we can get identical configuration. So is subsidiary, yellow line is for subsidiary axis, 1 rotation, second from this side, and third between 2 edges, and fourth one is this side. So in PTCL4 there is C4 and 4C2, right? And this is between 2 edges, 2CL, this CL, this CL, this, and this. This is CL from this C2, and C2 is from this side, right? So there is a 4 C4 and 4 C2 in 4-fold axis of symmetry. There is also an example of C5, C3, sorry, iron pentacarbonate. The highest order rotation axis is the principal axis. This orange line, that is C3. This is a 3D configuration, and it is chosen as z-axis, and other axes are subsidiary axis. So this आज के लिए इतना काफी है, and next proper axis of rotation, explain of symmetry and improper axis rotation will be discussed in next video. Thank you so much.